Hello, my name is Brian McDonald. My student number is 37996. I'm an electrical major and I'm practicing for an interview for somebody who is looking for somebody to fix a doorbell. To answer your question, Mr. McDonald, about why your doorbell stopped working, I would need to examine it first before I can give you the specifics. But I can tell you that most likely you're looking at one, maybe two problems out of a possible four, maybe five problems that are likely to exist. But before I can tell you what's wrong with it, I need to look at it. Yes, Mr. McDonald, you may have to buy some parts, but the good thing is the parts aren't expensive. You're probably talking at less than $30. It all depends on your taste. It takes 45 minutes to an hour to complete this job. In the event of something unforeseen happens, add another hour and a half, but usually in 45 minutes, the job is complete. If it's only the button that needs to be fixed, any amount you give me over $35 will be fair. If it's the button and the chime, any amount you give me over $50 will be fair. If it's a problem with the transformer, I'd want to take a look at it first before I tell you an amount. But you can rest assured that any amount that you give me over the amount that I tell you will be fair. How long will it be before it breaks again? Once I put it in, that's going to be like a brand new installation. Why should you think I could fix your doorbell? Well, during the past 3 months, I've been taught in classes at BTVI, Bahamas Technical and Vocational Institute, been taught by a phase 3 electrician. And he and his colleagues have tested myself and my classmates, and they have announced to my class during the second week of October that we were competent at installing household electrical appliances. We install lights, whether it's on a single switch or whether it's on multiple switches. We install receptacles, 120 volt receptacles. We install 240 volt receptacles. We install photovoltaic systems, and the list goes on. Before I close this video, I'll make a list for you and put it on another slide. But no question, I can fix your doorbell. I'm going to do a couple of things. I'm going to check your button. I'm going to check your chime. Notice with the chime that the front doorbell has a sound and the rear doorbell has another sound. Alright, so I'm going to check that to make sure that that's working properly. I'll check your transformer and I'll check your wiring. I'll also make sure that your chime is properly lubricated. These are the tools that we'll use to check the doorbell. We use a Phillips screwdriver, we use a straight edge screwdriver, we use a toothbrush, we use a linesman pliers, we use a channel lock pliers, we use a voltmeter, use some low voltage wire, we'll use some regular 12 gauge wire, and we use some contact cleaner, and this is what we'll use to lubricate the chime. Alright, we don't want to use that other 40 oil. That causes things to get stuck. And in case we have to change some parts, we have buttons for the doorbell that we could change. We have a transformer, it could be changed. And this is your chime, that too could be changed. Earlier in the video, I said that I would come back to you and tell you more about some of the installations that we do. This here is where I want to do that. Wire single or multiple lights or loads operated by one or more switches. A light and a load, it's the same thing. So in one place we could have a light, but it could also be a different fixture, and that's what we do. So we single, multiple lights, one switch, more than one switch, we do that type of wiring. We wire photovoltaic dusk to dawn switches. These are switches that are activated depending upon the amount of light around it influencing it. It's a little bit more, how should I say it? It's slightly more complicated to wire than a regular switch, but at the end of the day, it's a switch nonetheless, and only a switch. GFCI and AFCI receptacles. These receptacles are for safety. What the GFCI is a ground fault circuit interrupter. What that means is that if, let me give you an example. Let's say that you running a load, let's say it's a light coming through the circuit. Let's say the circuit is pushing 6 amps, and that's on the hot side or the entry side. On the exit side, the circuit is measuring less than 5.5 amps. That would be enough to trip the circuit, because what it's saying is that more electricity is going in than what's coming out. So it means that electricity is being leaked somewhere, and that could cause a problem. All right, that could lead to fatal electric shocks. The AFCI receptacle is another safety device that is used for arc faults. What an arc fault is when sometimes you may notice if you switch on a light or push in a plug, you might see a quick spark. But that spark could also be something that lasts like a permanent. Let's say if you have some broken wires or an overheating breaker, a short circuit or something overloaded. The electricity that jumps across from one pole, from one part of the wire, trying to get to the other pole, that could actually cause a fire. And this is what the ground fault circuit interrupter and the arc fault circuit interrupter are designed to do. So the ground fault circuit interrupter, that would protect from electrical shocks. The arc fault circuit interrupter, that would protect against overloads and short circuits, while the arc fault is the most common cause of fire. Another thing that that I could tell you about the GFCI and the FCI is the GFCI, the ground fault circuit interrupter. They would be in places where electricity and water would share the same room. Kitchens, laundry rooms, bathrooms, swimming pools. Okay? And the AFCI would be in places where, for the main part, they would be in places where people go to sleep, but the national codes are now starting to ask that they be in every room of the house. They go a long way in protecting from fires and those type of disasters and fatalities. The single and double pole GFCI arc fault breakers. These work similar to the receptacle in that these would cut off if there's electricity escaping or if there's an arc someplace, but instead of it being a receptacle where you would plug in your appliance, these actually control the entire circuit as it applies to your house. 120 volt 15 amp receptacles, you may be kind of more familiar with these and the other things that I have talked about, but when we wire these so that both parts, you'll notice that the receptacle has 2 parts to be able where you can have 2 different appliances plugged in. We can set these up where both parts are live all the time. We can set it where one part is live and the other part is worked by a switch. We can have it so that both parts will work by separate switches. We could have it so that one part is live and another part is disconnected. So whatever it is you're trying to do, the wiring solves this. We also wire 240 volt and 208 volt receptacles. These are for somewhat heavier appliances, your dryers, your washers, your refrigerators. Now, and earlier in the message I talked to you about the tip. Everybody likes a tip. This is what we're talking about here right now. If you have a 240 volt appliance, let's say a water heater, it'll burn less current than a 120 volt. Not going to get into the mathematics behind it now, but if you buy appliances that run on 240 volt, your electricity bill would be lower. We work with fluorescent lights. What we found about fluorescent lights is when you're working with fluorescent light, that's when you have to be on your best behavior as far as paying attention goes, because fluorescent lights, they could be a pain to get it right if you do something wrong. So from the first step with the fluorescent light, you start giving that your attention. And water heaters, we look at water heaters, we wire them for installation, we troubleshoot them for if it's not heating properly, no heat, hot water coming but not enough, etc. We have different ways to go about checking and fixing them, whether it's a thermostat, whether it's an element, and so on and so forth. We also work with dimmer switches. All a dimmer switch is just a resistor whereby the amount of voltage flowing into the light or into the load is changed, can be manipulated. Instead of there being a constant 6 volts, we could fix it so that there are 3 volts, 6 volts, 9 volts, 12 volts, etc. And the list is as large as the imagination. Once it uses 120 volts, 240 volts on a single pole, we can deal with it.